Graph theory becomes useful when you start planning more complex projects with multiple tasks and multiple people or teams involved in completing the tasks. One team may be depending on another team to complete a task before they can complete theirs. The project manager will want to know the project is on schedule, or for that matter, they want to know how long the project is likely to take before they even start it. Graph theory gives you the basis for planning a project, understanding the dependencies between tasks, and establishing a timeline for completion of the project. If you know anyone who got married, they might have used a wedding planner. To plan a wedding, you have to make a ton of decisions and complete a bunch of tasks in a specific time, and often in a specific order, in order to get everything done in time for the wedding. While it may not be obvious to the person planning the wedding, their planning is underpinned by graph theory. Have you ever used Google Maps to find directions between two locations? Have you ever been surprised by the route that it suggested? Google Maps uses some very complex graph theory to decide what route you should take. Every day I use Google Maps to navigate from school to my home in Ottawa. Google has taken me on at least 8 different variations to get me home most efficiently. If we look at a possible trip from school to the train station in Ottawa, for example, we can see that Google evaluates several different routes and picks the best one for us. This is all based on graph theory and a whole ton of historical and current data. If you're organizing the deliveries for a shipping company who needs to deliver packages to many different locations, you should be using graph theory to decide what order to do the deliveries in to minimize delivery time and fuel consumption. If you've ever worked in a busy commercial kitchen, graph theory is underlying the order that the tasks are done to maximize efficiency of getting food to the table of customers. You wouldn't start preparing the spaghetti sauce after you've cooked the pasta. You can make sauces well ahead of time, but you can't cook vegetables until they're just about ready to be served. In some cases, however, you can chop the vegetables ahead of the time when they need to be cooked. A finished dish requires the sauce as well as the vegetables and the meat, which all have different cooking times and preparation times, to all come together at once. The chef might not know it's graph theory that they're using, or even make visual use of the tools like we're going to do, but they plan the task for the kitchen staff using graph theory just the same. Finally, software planning relies heavily on graph theory, although often they use software that does the work for them. Graph theory is also the basis for game development, for making the decisions that happen during a game. If you're interested in how it applies to game development, there's an interesting video that you can check out. As we start this new unit on graph theory, the first thing we have to do is establish the vocabulary we're going to use. There are a lot of new words connected to graph theory, so the first few lessons are heavy on definitions and understanding fundamental concepts. We need this foundation before we can get to using graph theory to do something useful for us.